What are the best redundancy strategies for SCADA systems? Imagine a control room where everything runs smoothly, even if some parts fail. That's what redundancy in supervisory control and data acquisition systems is all about. These systems are vital for managing critical infrastructure like power grids, water treatment plants, and factories. If one component stops working, the entire operation shouldn't come to a halt. So, what are the best ways to make sure that never happens? One key approach is having backup servers. You set up a primary SCADA server that handles all data and control functions. Alongside it, you have a standby server that stays synchronized with the main one in real time. If the primary server crashes, the backup takes over instantly, keeping everything running smoothly. This process is called failover, and it's essential for continuous monitoring. Next, multiple communication paths are crucial. Instead of relying on just one network, use several. For example, you might have Ethernet rings and separate telemetry links. If one network fails, the system automatically switches to another. This way, data keeps flowing without interruption. Reliable communication is the backbone of effective control systems. Power supplies also need to be foolproof. Using uninterruptible power supplies, dual power feeds, or backup generators ensures the system stays powered during outages. Dual power supplies with diode modules can keep the system running if one power source fails. Fast-acting circuit breakers monitored by the SCADA system can quickly disconnect faulty power and prevent damage. Data collection devices like remote terminal units and programmable logic controllers should also have redundancy. Installing multiple sensors and controllers for critical measurements means if one fails, others can take over. Using different sensor types, such as ultrasonic or float switches, adds extra reliability and helps detect mismatches early. Data backup is another pillar. Storing data across multiple synchronized databases ensures that information is never lost. Following the 3-to-1 rule, 3 copies of data on at least 2 different media types, with one offsite, protects against disasters. Regular backups of system configurations and historical data keep everything safe and easy to restore. Geographic redundancy adds another layer of security. Having backup systems at different locations, known as hot standbys, protects against site-specific issues like natural disasters. A detailed disaster recovery plan should include procedures for manual operation, testing, and quick recovery. Operator interfaces must also be reliable. Using redundant human-machine interfaces or workstations ensures operators can monitor and control the system even if one interface fails. Network device redundancy, like backup routers and switches, keeps communication lines open. High-availability network designs with automatic failover prevent network breakdowns. Finally, automated failover mechanisms are vital. These systems detect failures immediately and switch to backup components without needing human intervention. This minimizes downtime and keeps operations running smoothly. In industries like energy, water treatment, and manufacturing, these redundancy strategies work together to keep systems running without interruption. The overall goal is to combine hardware backups, network resilience, data protection, and disaster planning. This way, SCADA systems stay operational, no matter what challenges come their way.